Okay, so we left off with the complement rule right here. So the probability of E complement is equal to 1 minus the probability of E. Now the reason it's 1, of course, is because of the fundamental rule of probabilities way back in chapter 1, or 5.1, excuse me, that all probabilities right there have to sum up to 1 in a sample space, right there on page 3. So let me go back down to where we were. Oh, there it is. All right, what is the probability of randomly selecting a Jackson resident who is not O negative? Okay, so the O negative is right here. So what's the probability of you not selecting somebody who's O negative? Now you can do this two ways. You can add up all these different numbers, or you could take the complement rule, right? So not O negative would be equal to 1 minus the probability of O negative, which would be equal to 1 minus, and then look up here for the empirical probability in Jackson, it's 0.1048. We're actually a little bit higher than the national average. And then I'll bring up Excel to do that. Although, honestly, I could do that one in my head, but equals 1 minus 0.1048. So it's 0.8952. There we go. All right, now what about Wheel of Fortune? What is the probability that you land on money? Right? Money, money, money. So you could figure out all these different spaces and count them. But you can also remember, hey, we already found the probability of not landing on money, right? So the probability of land on money would be equal to 1 minus the probability of not getting, getting money. Okay, and we already found that way back up above, and it was 3 out of the 24 spaces are not money, the bankrupts and the lose a turn, which means it gives us a grand total of 21. Oops, if I can type it correctly, 21 out of 24. All right. Now in the game of craps, you lose if you land on snake eyes, right? Two ones, 1 and a 1. It's called snake eyes by gamblers. So what's the probability that you do not roll snake eyes? All right, so the probability of not snake eyes. Okay, well, why don't we find the probability of snake eyes and take it away from 1? Right? That's going to be a whole lot easier than trying to figure out all the different rules you can make, because there are tons of rules in craps that are not snake eyes, right? Okay, so first thing we're going to have to do is we're going to have to figure out the probability of snake eyes. Okay, but we already did. You just don't remember it. It's way up here. Well, we didn't really figure out its probability, but we at least have the sample space constructed. There it is on page 8. So snake eyes is this top corner right here, 1 and 1. Okay. And the sample space, because it's a 6-sided die and another 6-sided die, it's 6 times 6, which makes 36. So the probability of snake eyes is 1 out of 36 possible rolls that you can have with 2 6-sided dice. So that means, actually I can just bring this up. This is 1 out of 36. So the probability of not getting snake eyes is 1 minus 1 out of 36. And in other words, in algebra class, you learn that's 36 out of 36, take away 1 out of 36, which is 35 out of 36. And that is your final result right there. I'll scroll back down to it so you can see. Takes me a minute. There it is, right there. Cool. All right, next. Suppose you're going to randomly pull a card from a 52 card deck. What's the probability of not drawing an ace? The probability of not ace, let me just do it this way, is equal to 1 minus the probability of ace. And we all know, hopefully, there's 4 aces out of 52 cards in the deck, which would be 48 out of 52. That's the probability that you are not going to get an ace. And of course, you can find that decimal with Excel. All right, I'm going to fill in these numbers from our earlier Harry Potter data, and I'll be back with that for the next one.